Hello kids, this is Ankit Jangam. I welcome you to the 7th part of your chapter Gravitation. In today's video, we're going to do exercises. So let's start with the question number 13. Okay, now a ball is thrown vertically upward with a velocity of 49 meter per second. Calculate the maximum height to which it rises. Okay, in this particular given question, what we have given, a ball which has been, which is thrown upward, and we have initial velocity u is equals to 49 meter per second. Now what we need to find, calculate the height, maximum height it reaches. क्योंकि बॉल ऊपर जाएगी, एक टाइम के बाद ये क्या करेगा, ऊपर पहुंचने के बाद रुक जाएगा, एज एक्सेलरेशन दैट इज ग्रेविटी वो नीचे की तरफ एक्ट करी होगी, and the value of g is 9.8 meter per second square. In this particular question, as the object get stopped, एक height reach करने के बाद वो रुक जाएगा, due to that its final velocity here is 0 meter per second. Okay, now चलिए करते हैं. Okay, so we have u that is 49 meter per second, v 0 meter per second, and g that is minus 9.8 meter per second square, and h here that we need to find. So by applying third equation of motion, we get the formula v square equals to u square plus 2gh. Okay, now by applying the values, we get 0 square equals to 49 square plus 2 minus 9.8 into h. By simplifying this, we get the value that is 2 into 9.8, h is equals to 49 into 49. By simplifying, we get h equals to 49 into 49 upon 2 into 9.8. By simplifying it, we get we remove this value of point, we get 490, and 98 is divisible by 490, that will be 1. We get here actually 5. Okay, now by multiplying it, we get the value. When we multiply 49 by 5, we get the value that will be 445 upon 2. So the overall value will be 122.5 meter. So the height, the gain by the ball will be 122.5 meter. Let's check the answer. Okay, here it take the formula. Okay, he applied the formula, and what it get, same here, the value of height which it reach 122.5 meter. Let's check the another part of same question, that is the total time it take to return to the surface of earth. Now what we know, that our velocity, initial velocity is 49 meter per second, v is 0 meter per second, and gravitation is minus 9.8 meter per second square. What we need to find, time here, we can use the height which we have already obtained, and we simply don't need to. What we can take, we'll apply first equation of motion, that is v equals to u plus gt. Now by putting the values, we get 0 equals to 49 plus, okay, bracket of minus 9.8 and the time. By simplifying, we get 9.8 t equals to 49 and the t equals to 49 upon 9.8. By simplifying, we get here 498. 98 by 490. We can divide it. The time taken by ball to reach the topmost height is 5 seconds, as the time which taken by this ball to reach its maximum height will be equals to the time it will take to get back to the same position. That means 5 seconds it will take for ascent and 5 seconds it will take to get down. So the total time will be here, due to that 5 plus 5, and that will be 10 seconds. Let's check the answer. Now, what did this take? It also solved the question with the first equation of motion, and by applying the formula value, it gives the time t. The time t for reaching to the maximum height by, and we already know the time of ascent is totally equal to time of descent. The time taken by ball to reach its maximum height is equal to the time it takes to get back to the same position. Therefore, the total time will be 10 seconds. Let's move to the second question. Okay, a stone is released from the top of a tower of height 19.6 meter. In the given question, height is given as 19.6 meter. Calculates its velocity just before touching the ground. Now, in this question, the initial velocity is 0 meter per second, as the ball or the body has or stone has been released. Due to that, it will fall, but its initial velocity will be 0 meter per second. What we need to find is v. Okay, and we have another data here, that is g equals to 9.8 meter per second square. Now, as the stone falling downward, the value of acceleration will be positive. Due to that, we'll take the value of g 9.8 in this question. Okay, let's solve the question now. By applying third equation of motion, that is v square equals to u square plus 2gh. Okay, by putting the value, that is u square plus 2, the value of g, that is 9.8, the value of height 19.6. Now we get v square equals to 19.6 into 19.6, as 9.8 into 2 give you 19.6. So the value v square is equals to okay, the value will be 19.6 into square. So the value of v will be 19.6 meter per second. Now let's check the value. Okay, what it take third equation of motion as us, it solve the value. By further solving, what we get, that v is equals to 19.6 meter per second just before it touched the ground. Okay, let's move to the another question. Okay, a stone is thrown vertically upward with an initial velocity of 40 meter per second. Now here the u is given 40 meter per second. Now taking g, here the value is given 10 meter per second square, but as the ball is rising upward, the value of g will be minus 10 meter per second square. Now find the maximum height reached by the stone. How much? In this question, what we need to find, h, Okay, in this question, we also get the v equals to 0 meter per second. As the stone will get 0, its velocity becomes 0 as it reaches its maximum height. Okay, what is the net displacement? We also need to find net displacement and the total distance covered by the body. Let's find this. Okay, what we need to apply here, that will be third equation of motion, that is v square equals to u square plus 2gh. Okay, now applying the value, what we get, 0 square equals to 40 square plus 2 into minus 10 and h. Okay, now by simplifying, what we get, 20h is equals to 40 square, and the value of h is equals to 40 square upon 20, and that will be equals to 80 meter. Okay, now what we need to find, the total displacement. Now the stone, okay, which has been thrown upward, will move upside, and then it reaches its maximum height, that was 80 meter, and come back to the same position. So that was 80 meter. So the distance covered by the stone will be 80 plus 80, that's equals to 160 meter. But the displacement is 0 meter as it come back to its original position. Chalo, just check the answer. Let's check the answer. Now, according to the formula, third equation of motion that it had applied, by solving the question, we get the value, the distance, maximum height reached by the stone is 80 meter, as the downward, the total journey 160, while the displacement will be 0 meter. Let's move to the next question. Okay, now what we need to find, we need to calculate the force of gravitation between Earth and the Sun. Okay, now the formula for that will be F equals to capital G mass of Sun into mass of Earth, and definitely distance between them, square of that. Now here mass of Earth is given 6 into 10 to the power 24 kg, mass of Sun is given 2 into 10 to the power 30 kg, and the distance between them 1.5 into 10 to the power minus 10 to the power 11 meter. Now by putting all these value in the formula, what we get, we'll get, now the value of capital G, let me mention it, that will be 6.7 into 10 to the power minus 11 Newton meter square per kg square. By putting the value 6.7 into 10 to the power minus 11 into 2 into 10 to the power 30, that's the value of mass of Sun, and mass of Earth, that is 6 into 10 raised to power 24 divided by 1.5 into 10 raised to power 11 whole square. Now, by simplifying this, what we'll get? We'll get 6.7 into 2 into 6 upon 1.5 into 1.5 into 10 raised to power minus 11 plus 30 plus 24 and minus 11 into minus 11. Now, by solving this all and by removing the dots, we got the value 67 into 2 into 6 into 10 upon 15 into 15, and by solving this all, we'll get the value nearly 10 raised to power 21. By solving it further, we'll get to 5. Dividing it with this, we'll get here 5. Now, by multiplying this all, we'll get, by further solving this whole value, we'll get the value of 35.733 into 10 raised to power 21. As this point, as we're putting the whole value, hold the values of 0 here at the 10 as the power of 10, we'll simplify this value and write 3.573 into 10 raised to power 22 Newton, or simply the force will be written as 3.57 into 10 raised to power 22 Newton. That will be our answer. Let's check the value. Okay. By simply applying the formula and putting the values in the right way, we'll get the answer. By solving it, we get the answer 3.57 into 10 raised to power 22 Newton. Let's move to the next question. The question is, a stone is allowed to fall from the top of a tower 100-meter height, and at the same time another stone is projected vertically upward from the ground with the velocity of 25 meters per second. Calculate when and where the two stones will meet. Now let's take a tower of 100 meter here. One stone which has been released from this height, its initial velocity must be 0 meter per second, and the acceleration due to gravity on this will be 9.8 meter per second square. It will be positive for this case, as the moment of this stone will be downward. As the moment of this stone is downward, the value of g here will be 9.8 meter per second square. It will be positive here. Okay, another case. As the another stone which has been thrown upward with the initial velocity of 25 meter per second, and the acceleration due to gravity for this will be minus 9.8 meter per second square, as it is moving upward. Now they both meet a particular point. Let's consider at this point the time was t. Okay, the distance covered by stone 1 will be s, and the distance covered by this another stone will be s dash. I guess hopefully all understand this question. Now, what we need to find, calculate when and where. So we need to find either s or s dash or the value of t. Let's do this question now. So first thing that we need to solve, that we need to find the value of s, s dash and t. Okay, so let's find for the stone which is falling downward. That means we need to find the value of s first. So by applying the first equation of motion, as we have given values are s, g and u. We do not have any v here. Okay. So by applying second equation of motion, or we can use third equation of motion, that is v square, by applying second equation of motion, that is s equals to ut plus half gt square. Now for this particular question, the value of u is 0, the time which we do not know yet, and the value half into 9.8 as the value for this particular, the value of g for this particular case will be positive t square. By solving this, we get the value of s, that is 4.9 t square. Okay, let's keep it here. Now, for another case, when the stone is going upward, we have u 25 meter per second and g, that is minus 9.8 meter per second square. Let's find the value of s dash. Now, for this s dash, the formula will be the same. U dash t, let's take this u dash plus half gt square. Okay, by applying the value u dash t is u dash t, that will be 25 t plus half into minus 9.8 t square. By further solving, we get that s dash will be 25t plus, not plus, minus, due to this sign of g, minus 4.9 t square. Okay, now this will be the value of s dash. Now as the height of tower was 100 meter and both the stones are meeting at a fixed point, that is s from above and s dash from downward side. So summation of s and s dash will be equals to 100, that is 100 is equals to s plus s dash. Now taking the value of s and s dash, we get 100 is equals to 4.9 t plus 25t and minus 4.9 t. By solving this, what we got, 100 is equals to 25t. Now further solving it will give you t is equals to 100 by 25, so the value will be 4 seconds. Now we got the time, we still need to find the distance where they'll meet. Okay, let's try to find the value of s, which will be very easy. Okay, by finding the value of s. Now the s is equals to 4.9 t square, that is 4.9 into 4 square, that will be 4.9 into 16. Now further solving this will give us, that will be 78.4 meter. So to find the value of s dash, we can write 100 minus s. Okay, now by solving it, 100 minus 78.4 will give you 20.6 meter. That will be the height from the downstairs. Okay, let's find the value. Let's check whether we have done the correct answer or not. Now, by applying the value, okay, further solving, we get the value of s will be 4.9 t square, and for the second stone, we take the value s dash and g 9.8 meter per second square. Further solving will give us the value of s dash, that was 25t minus 4.9 t square. Further solving, as we know, s dash by s is equals to 100. We find the value of t, which was 4 seconds. By further solving, we get the value of s. That means the distance covered by the stone which was falling downward, and the distance covered by the stone which was rising upward. Okay, let's move to the next question. Now, what's in this question? A ball is thrown vertically upward, vertically returned to the thrower after 6 seconds. A ball has been thrown upward and it has thrown vertically, and it returned to the thrower same time. It take total time, that is 6 seconds. That means time taken by the body or the ball to reach its maximum height was 3 seconds, and returning from its maximum height to back to the thrower was 3 seconds. Now, find the velocity with which it was thrown upward. So we need to find u in this question. Okay, as we know, in this question, in for this particular case, the time become 3 seconds. Okay, for this particular question, the time become 3 seconds as whatever time taken by the body to reach its maximum height. Now, its velocity, its final velocity here was 0 meter per second. We need to find u, and the g here, as the ball has been thrown upward, it will be minus 9.8 meter per second square. Now, let's solve the value by applying first equation of motion, that is v is equals to u plus gt. Putting the value 0 equals to u plus minus 9.8, time will was 3. The value of u equals to 9.8 into 3. By the multiplying, we'll get the value 4.29.4 meter per second. Okay, let's check. Okay, first the value has been given. Let's take the time. Time taken was 3 seconds, as the final velocity for the ball to reach its maximum height will be 0. Due to that, by applying g as 9.8 meter per second square, by applying first equation motion, we get u equals to 29.4 meter per second. Let's move for the another question, and that was, what find the maximum height it reaches. Okay, now we need to find h. Okay, but we already have u, that is 29.4 meter per second. We have v, that is 0 meter per second, and we have g, that is 9.8 meter per second square, and it is negative. By applying here second equation of motion, we get h is equals to ut plus half gt square. Okay, by applying the value u, that is 29.4 into 3 plus half minus 9.8 and 9. Square of 3 will be 9 here. Okay, as this value, this equation become h equals to 29.3 minus 9.8 into 9.2. By further solving, this value will become h equals to 29.4 into 3 minus 29.4 into 3 upon 2. as we have already done that 9.8 into 3 is 29.4. By further solving, we get the value of h is 29.4 into 3 upon 2. By further solving, multiplying 29.4 by 3, we'll get 39, 27, 28, and 3, 6, 7, 8, 88. We'll get here 88.2. So the value of h will be 44.1 meter. Let's check the answer. Okay, by applying the value u equals to v, by applying second equation of motion, further solving, we get the value 44.1 meter per second. Let's move toward the next question, and that is we need to find the position after 1 second. Okay, now we know that the ball has reached its maximum height, that is 44.1 meter, and it has taken 3 seconds to reach its maximum height. After 1 second, it might be somewhere here. Okay, in 1 second. So we just need to find how much it had traveled from above to downward side. Okay, that will be very easy. What we need to do, we need to as in this position, the u will be 0 meter per second, g will be 9.8 meter per second square, as the movement of this ball is downward. Now time is given 1 second, and we need to find the height or the distance covered by this particular stone again. Okay, now by applying second equation of motion, that is h equals to ut plus half gt square. Now solving this will give us u, that will be 0 here, time 1 second plus half 9.8 multiply 1 square. This will give you the value of h, that is 4.9 meter. Now by subtracting 4.9 meter from the maximum height, that is 44.1 meter, we'll get the exact position of ball. So the exact position of ball will be 44.1 minus 4.9, and it will give us 39.2 meter. Let's check the answer. Now by, we know the distance, the time taken by 4 seconds will be 1 second. Further, by solving, we have already total height 44.1. We find the height, the distance covered by the ball from its maximum height, that was 4.9 meter. Further solving, after 4 seconds, we get the value 39.2 meter. Let's move to the next question. And that is, in what direction does the buoyancy force of an object immersed in a liquid act? Okay, now in this question, an object has been immersed in a liquid. Likely this might be the object. Now it is asking what will be the direction of buoyancy force. Now the buoyant force, as we know, it's an upthrust. So the direction of this upthrust will be above. Okay, let's check the answer. Now, an object immersed in a liquid experiences buoyant force in the upward direction. Let's move to the next question. Okay, why does a block of plastic release underwater comes up to the surface of water? The same question. Due to the action of buoyant force which is acting upward, the upthrust applied by liquid, the plastic block will come up. Okay, let's check the answer. Every submerged body is within two forces. Two forces are applied on every submerged body. One is gravitational force and another is buoyant force. Whenever which force is larger, it will act. If the buoyant force is larger on this plastic block, then the body will get up. Due to that, what will gonna happen? The block of plastic release under the water, it comes surface to the water as the buoyant force is larger than that of the gravitational force. Let's move to the another question. And that is the volume of 50 gram of a substance is 20 centimeter cube. If the density of water is 1 gram centimeter cube, will the substance float or sink? Now let's find out. The density of an object is generally equals to mass upon volume. In this particular question, the mass of that particular body is 50 gram and volume is 20 centimeter cube. By solving, we'll get 2.5 gram per centimeter cube, and this is definitely larger than the density of water. In that case, this particular object will definitely sink. Let's check the answer. As the density of an object is more, then the object will sink, and the density of an object is less, then the object will float. By solving this value, we get 2.5 gram per centimeter cube. The density of the object is much larger than that of water. Due to this, it will sink. Let's move to the next question. Okay, the volume of a 500 gram seed picked is 350 centimeter cube. Now, will this float or sink? We need to find that. And the density of water is given 1 gram per centimeter cube. What will be the mass of the water displaced by this packet? Now, we need to find what amount of water, mass of water displaced by this particular packet. Now, let's first find the density of this body. That will be mass upon volume. As the mass of the body here is 500 grams and volume will be 350 centimeter cube. By solving this, we'll get 10 upon 7 and the value will be 1.428 gram per centimeter cube, which is larger than whatever the value of density of water. Due to this object will definitely sink, and the mass of water released by this body will be equals to the density of water into volume of substance, and that will be, now for the mass of water release will be, the density of water was 1 gram per centimeter cube and the volume replaced by that particular substance will be 350. Due to that, the mass of water will be 350 gram. Let's check the answers. Now, as the density of the body will be 500 by 350, we get the 1.429. The substance, the density of the particular substance is definitely more than that of the water. Due to this, it will definitely sink. And the mass of water replaced by the substance will be 350 gram. Hopefully, you all like this part of the video. Till then, thank you.